piecewise functions. So our objective for this video, we want to define and use piecewise functions. We're also going to graph them. Well, what do we know? We already know what a function is. A function is a relation in which each component of the domain, each input value or each x value, corresponds to exactly one component of the range, the output values or the y values. Okay, so what's a piecewise function? Well, it's obviously a function. It is a function that is defined by two or more equations over a specified domain. Simply put, it's a function that is in pieces. Okay, let's take a look at an example. We'll do a couple of examples of this. Example 1. A speeding ticket's cost is defined as follows. If you were caught speeding up to and including 10 miles per hour above the speed limit, the cost of the ticket is $50. If you were found speeding more than 10 miles an hour above the speed limit, the cost is $7 for each mile per hour above the speed limit you were traveling. Okay, mathematically, we can write the cost of the ticket, so C is our cost, as a function of the number of miles per hour over the speed limit M. And it'll look like this. The cost as a function of the number of miles per hour over the speed limit is equivalent to. Well, here we have two possibilities. So we're going to write a curly bracket for two separate equations. The first one says, well, if you're up to and including 10 miles per hour, you're going to pay $50. And we put a specified domain on this. If your mile per hour above the speed limit, if M is less than or equal to 10. Okay, so it's a function that's in pieces, and we have a specified domain that directs us to what we're going to do in order to figure out the cost. Okay, that's this bullet here, the first one. The second bullet is if you are more than 10 miles above the speed limit. So the next domain, specified domain is M greater than 10. You're going to be charged $7 for each mile per hour above the speed limit. So your calculation is 7 times M. So here's our pieces. The first piece says you pay 50 if your miles per hour over the speed limit is less than or equal to 10. You pay 7 times the number of miles per hour above the speed limit you were traveling if your miles per hour above the speed limit is greater than 10. Let's make use of this. Now we have a piecewise function. So let us evaluate it. So find, that should say and, find and interpret A, the cost of the ticket when you are traveling 6 miles per hour above the speed limit. Okay, A. What is C of 6? Well, we know we have to look over here and look at our domains, and we know that 6 is less than or equal to 10. Okay, so 6 is less than or equal to 10. So C of 6 doesn't even involve a calculation. It's just 50. You're going to pay $50. Okay, so the cost for traveling 6 miles per hour above the speed limit is $50. Let's find and interpret C of 20. What is the cost when you're traveling 20 miles per hour above the speed limit? Okay, C of 20. Again, we need to determine which of these two am I going to use. Well, 20 is greater than 10. So I'm going to use this one. 20 is greater than 10. So C of 20 is equal to 7 times 20. In other words, the cost of traveling 20 miles per hour above the speed limit is $140. So they're obviously trying to ramp it up as you get further above the speed limit, trying to charge you more. Okay, let's take a look at how we graph piecewise functions. Okay, so I think I got it in there for you. My paper ready here. Graph the piecewise function defined by f of x is equal to x plus 2 if x is greater than or equal to, if x is less than or equal to 1, and f of x is equal to 4 if x is greater than 1. Okay, so we have two pieces and we need to come up with the points for each of those two pieces. The first piece, our x values, are when we're less than or equal to 1. So I'll put in 1, 0, -1, -2, and -3. Why not? Seem like pretty good values. Okay, f of 1 equals 1 plus 2, which equals 3. So this, to the point when we're in this area, when we're less than or equal to 1, one of the points is 1, 3. Okay, f of 0 is equal to 0 plus 2, which is 2. So a second point, 0, 2. A third point, f of -1 is equal to -1 plus 2, which equals -1. Equals +1. Good thing I have my notes next to me to check, to take a peek at and check. -1, 1. F of -2 is equal to -2 plus 2, which is equal to 0. So a fourth point is -2, 0. And f of -3 is equal to -3 plus 2, which is equal to -1. Get myself confused again. And the fifth point is -3, -1. Let's go ahead and graph that. I'm going to graph it first. You can do it either way. You could complete this first and then graph both. I'm going to go ahead and graph that. Okay, so here's my graph. I got plenty of space. X and f of x or y. Let's see here. 1 to -3. So here's 1, here's -1, here's -2, here's -3, and then -1 to 3. So here's -1, here's 1, here's 2, here's 3. 1, 3 is here. Now notice this is x equal to 1, so that's going to be a filled in dot. 0, 2 is here. -1, 1 is here. -2, 0, and -3, 1. So when x is less than, whoops, you can't see that, can you? There we go, that's better. When x is less than or equal to 1, this is the graph, and I apologize for a little bit of a crooked line there. That's a straight line. My points are hand-drawn, of course, and that's what the graph looks like. Now let's take a look at the next piece. When x is greater than 1. Now note, because 1, whoops, let's make sure you can see it. 1 is in both, so I need to put a 1 in here, but I'm greater than 1, so I'm going to include that point, but I'm going to leave it as an open circle because it's not equal to 1. It's anything greater than 1. For example, 1.0001. So I need to put 1 into my point. I need to calculate 1, but recognize it's greater than 1. So it's an open circle, not a closed circle like this one. So we'll put 1, 2, 3, 4, 5 as numbers that are equal to or greater than 1. Okay, and we're going to do, well, f of 1 is equal to 4. Okay, if 1 goes in, 4 comes out. So the point x, f of x is 1, 4. F of 2 is also equal to 4. F of 3 is also equal to 4. f of 4 is also equal to 4. Anything above 1 outputs a 4. F of 5 is also equal to 4. So those, oops, that should be a 5. So those are 5 points for the second piece of this piecewise function. And let's see, 1 to 5, so 2, 3, 4, and 5. And 4, so I gotta go to 4 up here. Okay, so again, at 1, I know it's 4, but I'm gonna put an open circle there because it's not equal to 1 for this piece, excuse me, right here. It's greater than 1. And then of course I've got 2, 3, fill in my circles, 4, and 5. So this is how the graph of that piece looks. And you can see now, you can see the two pieces in the graph and how they come together. Notice domain, all x values, negative infinity to infinity, but the range is different. The range goes from negative infinity to 3, including 3, and then it's 4, only 4. So negative infinity to 3 and 4 is the range. Okay, so there you have it. Piecewise functions, functions that are in pieces. Usually you'll see them as 2 or 3.